Hi, today I want to talk to you about arc fault circuit interrupters, or AFCIs. I'm going to explain and demonstrate exactly what an AFCI is. I'm going to explain and use animations to show you the difference between a series and a parallel arc fault. I'm going to explain the difference between AFCIs, GFCIs, and regular circuit breakers. I'm going to explain exactly what a combination circuit breaker is and a dual function AFCI, GFCI circuit breaker is. Since we're probably most familiar with what a GFCI is, let's start with that and we'll go from there. So a GFCI is designed to prevent a ground fault. That's why it's called a ground fault circuit interrupter. A ground fault is where current goes through a path that is not intended. And this path could be a person. And the GFCI will trip and stop that current from flowing and protect that person from being electrocuted. So that's a GFCI. A circuit breaker, or an overcurrent device, detects too much current flowing through a wire and will shut off power to that circuit and thus prevent that wire from overheating and potentially causing a fire. Now let's get to AFCIs, or arc fault circuit interrupters. They're designed to prevent electrical fires. An arc is similar to the spark you see if you walk across carpet and maybe touch a doorknob, or when you touch somebody and you both feel a small shock. That's also arcing. Arcing in wires is basically the air being ionized, and it occurs at very high temperatures. And this occurs when the wire gets damaged. Maybe just due to age, insulation on the wire is damaged. Maybe an extension cord is running under carpet, and after being walked on for many years, that insulation gets worn down. Maybe there's a wire running through a wall and somebody's trying to hang a picture and nicks the insulation with a nail. That can cause an arc. Just unplugging a wire improperly. Instead of using the actual plug, they pull the cord. This can damage a wire. There's a lot of things that can damage wires, and this can lead to electrical fires. So you have parallel arcing, which would be the arcing occurring from the hot wire over to the neutral wire or to the ground wire. For this parallel arcing to occur, the insulation on the hot wire has to be damaged. And then you have series arcing. That's where the arcing occurs on the hot wire. Because of a break in the hot wire, the electricity is jumping over, basically crossing that break. Arcing can also occur when there's a loose connection, maybe at a light switch or an electrical outlet. The screw is not tight and there's a poor connection. Maybe you've heard buzzing on a light switch or an electrical receptacle. That buzzing is arcing occurring. Now, if you hear that buzzing, that doesn't mean that a fire is imminent, but it does mean that arcing is occurring and that connection needs to be tightened. Anyway, so you've got the two types of arcing, series and parallel. When arc fault circuit interrupters first came out in 1999, they only had AFCIs that protected against parallel arcing. But now they also protect against series arcing. So they're much more effective at preventing electrical fires. The type of AFCIs that prevent both parallel and series arcing are called combination type AFCIs. Now they also have breakers that provide both the GFCI, or ground fault protection, and the arc fault protection. Those are called dual function circuit breakers. Again, they provide protection against arc faults and against ground faults. And since they're circuit breakers, they also provide the overcurrent protection. So where are these AFCIs required? Well, when they first came out in 1999, they were required in all bedrooms. Well, the 2017 version of the National Electric Code says that all 120 volt, 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas shall be protected by AFCIs. So basically they're required on essentially every receptacle in the home that's a single phase receptacle. So any new home should have AFCIs throughout. And typically AFCIs come in the form of circuit breakers. You've probably seen the GFCI outlets in kitchens and bathrooms and other places. While there are AFCI outlets, they're not near as common as AFCI breakers. So typically when you have AFCI protection, they'll be in the form of circuit breakers rather than the receptacles. So to sum things up, arc fault circuit interrupters, or AFCIs, prevent electrical fires. GFCIs, or ground fault circuit interrupters, are designed to prevent electrocutions. and regular circuit breakers or overcurrent devices are designed to prevent too much current flowing through a wire, thus preventing that wire from overheating and causing a fire. Studies have shown that having AFCI protection in the home has decreased electrical fires by almost 50% in the US. So they are very effective and they do make homes much safer. I hope this information has been helpful to you. I really appreciate you watching. If this was informative for you, I sure would appreciate a thumbs up. I hope you have a great day.